immediately hits the brakes. The truck slows down uniformly, okay, with an acceleration of 5.8 meters per second squared for 4.15 seconds. It makes skid marks on the road, 63.4 meters long, all the way to the point of contact with the deer. Uh-oh. What was the speed that the truck hit the deer? Okay, so here we've got a truck coming down the road. I'll let you go ahead and draw out your favorite deer here. That's a horrible looking deer. Okay. Truck driver sees the deer in the road, immediately hits the brakes. It slows down uniformly with this acceleration, so I know that the acceleration will be negative 5.8 meters per second squared. Okay, so it's going to be braking. I also know that the time is 4.15 seconds. And I know that the skid marks on the road from where it started braking to the deer are 63.4 meters. Okay, so I know it's a kinematics right off the bat, so I'm going to go ahead and make my table. Change an X, VI, VF, A, T. Change in X here, of course, will be 63.4. Initial velocity, not given, unknown. Final velocity, ooh, that's what we're looking for. How fast is it going when it hits the deer? So final velocity is our question. Acceleration, okay, I have that, minus 5.8. And the time, I have that, 4.15 seconds. Okay, I've got three things. I got the one that I'm looking for, and I got the one that I do not care about. Okay, so we look at our kinematics, and we look for the one that doesn't involve VI, and we immediately see a problem. All of them involve VI. We don't have an equation that does not involve VI. So we have to solve for it. Okay, so we have to just solve for it. So we need to take a little detour. Before we can solve for VF, we need to solve for VI. So it switches the problem around. So now I'm going to look for one that does not have VF so I can get VI by itself. Okay? And that ends up being the equation change in X is equal to VIT plus 1/2 AT squared. Okay? So let's start plugging in for that one so we can solve for VI so that we can solve for VF. So it's a two-part problem. That's why it's the last one. X, that is 63.4. VI is now the thing that we will be looking for. Time, given in the problem, 4.15. Plus 1/2, our acceleration is negative 5.8. And time, again, is 4.15. Don't forget to throw that square up there. Okay, so now we need to solve out for VI. You see here we just have a number. So I'm going to figure out what that number is. I'm going to minus it to the other side. Well, actually, it's going to be a negative by the time I'm all done. So I'll probably end up adding it to the other side. And then I'll divide the whole works by 4.15. And that'll tell me what the initial velocity is. Similar to the previous problems, the initial velocity should be greater than the final velocity. So when we figure this all out, we'll see if our answer makes sense just by that comparison. Okay, so if you do this out correctly, you should get a initial velocity of 27.3 meters per second. Okay, now that we have that, we can add it up here to our table, 27.3. And that's not our answer. That's just part way there because we have to figure out what the final velocity is. Okay, so now we can grab a different equation, any of them that we like that have final velocity in it. Okay, so we go back to our paper and we go, okay, the easiest one is probably VF is equal to VI plus AT. Okay, so now we're looking for final velocity, which means we'll need that initial velocity, 27.3 plus our acceleration of negative 5.8 times our time of 4.15. Okay, now if we do this out, simple calculation, nice and easy, we should get that our final velocity is equal to 3.24 meters per second. Okay, it's a positive number, so we're still traveling in the same direction. It's less than the 27.3, the initial velocity, because we braked, so our final velocity, of course, is slower than our initial. But didn't quite brake hard enough. We ended up hitting the deer.